Welcome to Electron and now let's talk about the celestial sphere. What does that mean? Well, before we talk about celestial sphere, let's talk about the Earth sphere. Here's the Earth, well, my best interpretation of the Earth. And the lines here represent a grid system that we put on the Earth so we can find any location on the Earth. It's the latitude and the longitude. Latitude, of course, is the height above and below the equator. Longitude is a point on the Earth going around the Earth like this. Relative to the Greenwich line, which goes right through England, the small town Greenwich near London. And so we're able to find a grid system, or I should say we're able to find a point on the Earth using that grid system. Now, most people know it as the GPS. GPS is a satellite system that automatically calculates, through communication with cell phones and other communication devices, calculates the position of any point on the Earth relative to a grid system. So in astronomy, we've wanted to do the same thing, but with the entire universe. Now there's one problem. The location from which we observe the universe, the Earth, is always constantly moving. It is rotating, it's going around the sun, it wobbles, it does all kinds of things. The wobble and the change of the actual tilt and so forth is so slow that we can pretty well ignore it in the typical span of a decade or a lifetime. So the two most important motions that we have to deal with on the Earth is the fact that the Earth is rotating and the fact that the Earth goes around the sun, revolves around the sun. That makes a coordinate system of the universe kind of difficult to figure out. So what we wanted to do is we want to find some sort of fixed way of determining points in the universe, things in the universe, be able to put a coordinate system on it just like we did on the Earth. And our first problem is that the orientation of the equator of the Earth is not along the ecliptic. Remember, the Earth goes around the sun, and we call that plane that the Earth carves out, so to speak, as it goes around the sun, we call that the ecliptic plane. Now, the equator makes an angle of about 23.5 degrees relative to that ecliptic plane. But since we're observing from the Earth, and since we already have an equator to the Earth and we have poles at the Earth, it made a lot of sense to set up the celestial sphere, the coordinate system of the universe, along with the coordinate system of the Earth, same orientation. So we wanted the north and the south pole of the universe, so to speak, to be along the same lines of the north and south pole of the Earth. And we wanted the equatorial plane of the universe to be in line with the equatorial plane of the Earth. So if we imagine that we slice through the Earth at the equator, and then we take that slice and we move it out in all directions, forward, backwards, sideways, then we get this enormously large, infinitely large plane that now becomes the celestial equator, or the celestial equator plane. Everything to the north of it is north of the equator, everything to the south of it is south of the equator. So it basically divides the universe into two regions. The second thing we wanted to do is be able to point to the point directly above and directly below the Earth. So we have the North Pole of the Earth, and if we go straight up from there, we reach a point we call the North Celestial Pole. Well, it's not really a pole, it's kind of like a point. It's kind of like a line along the North-South Pole axis about which the Earth rotates. And if we extend that infinitely in one direction, infinitely in the other direction, when we point in that direction, we're pointing to the North Celestial Pole, and we're pointing to the South Celestial Pole.
Western astrology faces a fundamental problem. Ancient Greek astrologers devised their calendar over 2,000 years ago, At that time, they noted that on the 21st of March, the first day of spring, the Sun was in perfect alignment with the star constellation Aries. They took this date as the starting point of their zodiac, but because of a slow swing in the Earth's axis, the system is no longer accurate.
This apple is going to be the planet Earth, so we are all there on this surface, and the Earth is spinning, and it has an axis around which it is spinning. This axis is represented by this piece of wire. Now the Earth goes around the Sun, the Sun is in the center, but the axis of the Earth is not always like this. The axis of the Earth is doing what we call precession, so it's wobbling very, very slowly. Actually, this movement takes 26,000 years to complete, and this is a problem.
The problem lies at the exact point the Sun crosses the celestial equator. By taking the line of the equator on Earth and extending it, we form an imaginary plane into space. The Sun crosses this celestial equator on the first day of spring. But the exact point at which the Sun and this equator meet is slowly but steadily changing.
2,000 years ago, that point was here because the axis of the Earth was pointing in a different direction. So the meeting point between the equator and the path of the Sun was here in Aries. And the equinox, the point where both planes meet, is changing this point a long time.
Because of this change, the precession, the meeting point between the Sun and the celestial equator is slowly moving. Today, the Sun crosses the equator on the spring equinox, not in the constellation Aries, but in Pisces, and in a few years it will move into Aquarius.
And then 24,000 years or whatever from now, it will be back to Aries. So then astrology will be happy again.
If the Sun is not in the constellation we think it is when we're born, we're all reading the wrong horoscope and living the wrong future. We should be reading the one from the month before we were born. So Aries becomes Pisces, Pisces becomes Aquarius, and so on.